Hi, today my tips and tricks lesson is on solving systems of equations using the substitution method and the elimination or addition method. I'm going to start here with the substitution method and give you a couple tips and tricks. One is, here's our system of equations. We have the first equation, we have the second equation. The first thought is this set up for the substitution method? And one of the things I look for is to have a variable that only has an invisible one or no coefficient in front of it. So if you are solving for that variable, you won't get a fraction when you're trying to put something back into the equation. So as I look there, I would get halves if I solve for this x. I'd get fifths if I'd say for this y. So I'm going to solve for that variable right there, the y. So if I'm going to solve for y, I would subtract 3x from both sides. So I would turn this into y equals negative 3x minus 7. So that's my first trick, is that you look for the variable that doesn't have a coefficient in front of it that will make what you're solving for a fraction. So that's the first trick. The second is when you're substituting in, I always want to make sure that I am using parentheses. And when you substitute back in, you're going to substitute into the other equation. If you by accident substitute back into this first equation, then you're not going to get something that makes any sense at all. You basically get something like 5 equals 5, and you're like, okay, I know that. So anyway, we take this negative 3x minus 7, and we put it in for that y right there. So what we're going to get is 2x minus 5, and here I'm going to put in the parentheses, negative 3x minus 7 equals 1. So using those parentheses is very important. So by substituting in for that y, we now have an equation that just has x's in it that makes it easy for us to solve for that. So the first thing we're going to do is use the distributive property. One of the most common mistakes is to forget to distribute to the second variable right there. So I'm going to go 2x, and then it's negative 5 times negative 3x, which is positive 15x, and then negative 5 times negative 7, which is positive 35, and that will equal 1. So I'm going to combine these two, so this will be 17x, and then I'm going to subtract 35 from both sides. Notice I try not to do things in my head. And so this will equal negative 34. Our last step when we're solving for x is to divide by 17. So we get x equals negative 2. And that's one of our answers right there. Well, another common mistake is people stop right there, like, oh, I'm done, I'm solved for x. But you need to figure out which the other variable. So we need to figure out what x is and what y is because we're trying to find a point where these two lines cross. So this x equals negative 2 can plug back into either one of these equations because we're trying to find where the line crosses and that point is in common. So what I like to do is I take a look at both equations and I try to find the one with the simplest numbers involved. It's not too obvious in this case, but I'm going to pick this one just because there's a plain y right now and it will make it easier to solve for. So I'm going to take this negative 2 and put it into this x right there. So I'm going to do that up here. I'm going to go 3 times negative 2 plus y equals negative 7. So then I do this multiplication, so it's negative 6 plus y equals negative 7. And then I'm going to add 6 to both sides, and I get y equals negative 1. So our final answer would be the point negative 2 comma negative 1. And that would be our answer to the substitution. So my 3 tips was to look for the variable that doesn't have a coefficient from it. The second one is use parentheses to substitute back in. And the third one is don't forget to solve for the other variable. Choose the equation, though, that is the easiest numbers to deal with. So now I've done a quick switch and I've changed this to the elimination method, but I have the same two equations to solve my system of equations. Forgot my pen. All right, so the elimination method is we want to add these equations together in order to eliminate one of these variables. So I choose which one would be easier. In this case, I think it would be the y's because I only need to change one of them. The object is to get them equal but opposite for the coefficients. So in order to get these opposite, I would need to make this a positive 5y. So when I add a negative 5y to it, it will eliminate the y's. So what I'm going to do, and this is my first trick. A lot of times books say, okay, I'm going to multiply by 5. Well, what this does is this invites a lot of silly mistakes. So instead, I distribute the 5 right away. So I'm going to put a times 5 here. I'm going to put a times 5 here. And I'm going to put a times 5 here. This is the one that I always forget. So what I'm going to do now is rewrite both equations. So I'm not going to have to jump from one to the other. So I'm going to go, okay, this one stays the same. 2x minus 5y equals 1. And this will be now 15x plus 5y equals negative 35. And you'll notice some similar numbers between this method and the other method. So now when we add these up, we're going to get the negative 5 and the positive 5y, and they will eliminate. So the 2x plus 15x is 17x. The negative 5y plus 5y is going to disappear, and that equals negative 34. And then again, our last step is to divide by 17, and we get x equals negative 2. Now I'll leave this off here because we already remembered everything from here is the same as with the substitution method. We go back and we choose which equation we want to plug the negative 2 back into to solve for the y. In this case, you want to go into the original. You don't want to go to the one with bigger numbers. The object is to get smaller numbers and fewer negatives because those are the places where you could make mistakes. So those are my hints and tips and tricks for the substitution method and the elimination method. So I hope that helps.